All right, guys, welcome to lesson 12.3. This is going to be our last lesson for Unit 12. It's a very short lesson, very short unit. This one we're going to see how factoring can come in handy whenever you want to simplify expressions that have trigonometric expressions in them. So let's review factoring a little bit before we begin. We're going to be using three factoring methods that we've talked about before. First of all, there's the difference of squares method. That's when you have two numbers that are perfect squares being subtracted. And in that case, you could take the square root of the first one and put it here and here, then the square root of the second one and put that here and here, and just put a plus between one pair and a minus between the other, and that's what we call the difference of squares method for factoring. You've got to be careful. It has to be subtraction here. It can't be addition. So if you have a squared plus b squared, that actually doesn't factor. So be aware of that. Moving on, another factoring method we've talked about is the Gcf method. That's when you have two terms that are being either added or subtracted, so it doesn't matter if that's a plus or a minus in the middle. But all that matters is that they have something in common. So you see that each of these things have an a. And what we're going to do is we're going to take that a out and then bring it to the front. And the result is something that looks like that. And that's called taking out a greatest common factor. So that's another factoring method that we're going to be employing today. And then finally, anytime you have three terms being combined somehow, we're going to go with the box method on that. That's the one where you put the first number in the top left box and the last number in the bottom right box, and you find the numbers on the outside that work such that these numbers here and here end up adding together to make the middle number. So that's stuff that we've done before, and we'll be using all of those factoring techniques for the problems that we're doing today. All right, so I'm going to do an example showing you how you can use factoring on trigonometric expressions, and it has one of each factoring method associated with it. Okay, now let's go ahead and take a look at example 1. Now, you may not need to change these into just basic letters, but that's what I'm going to do first. So I'm going to take this, and I'm just going to replace them with basic letters. So instead of cotangent squared, I'm just going to put c squared, and I'm just going to remember in my brain that c stands for cotangent. And then minus, instead of sine squared, I'm going to put s squared. Now, you don't have to do that, but I just find that for some students, it's really helpful for them to write them as single letters. It helps them be less overwhelmed by what they're looking at. But if you can leave it like this and get the factoring done, more power to you. All right, so now what factoring method is this? Well, you'll notice I've got two numbers that are perfect squares and they're being subtracted. That is a difference of squares method problem. And so to factor these ones, we take the square root of the first term, which is c, and we're going to put that in the front of a pair of parentheses twice. And then we're going to take a square root of the last term there, which is s. We're going to put that last in each pair. And we just make one a plus and one a minus. And that's our answer. But before we circle that, I was about ready to circle that. We don't want to leave it as c and s. We want to put it back what it really was. So c really stands for cotangent of x. And s really stands for sine of x. So let's go ahead and put that back before we call it quits there. And there you go. So we just factored an expression with trigonometric expressions in there using the difference of squares. So the first thing I did was I rewrote it as basic letters, then I applied the factoring strategy, and then I put back what the letters represented. All right, let's go ahead and take a look at number 2. All right, so once again, I'm going to replace the trigonometric expressions with the letters. So instead of sine, I'm just going to call it s. So sine squared is going to be s squared, plus sine is going to be plus s. Now, what method would I use here? Well, this one has something in common in each one of these terms. They both have an s. So for this one, we're going to go with the Gcf method. Okay, so I can take an s out. If I take an s out of this one, there's still one left. And if I take an s out of here, it leaves a 1. And the reason for that is because what we're doing is we're dividing by s when we take it out like that. So if you divide s by s, you get 1. And so there's that. Now before I call it quits, we're going to replace the letter with what the letter represented. S represents sine of x, right? So I'm going to replace s with sine of x, and the result will be what we want. And there you guys have it. Okay, let's go ahead and do one more example before I let you guys practice some of these. So this one I'm going to call that t squared plus 4t plus 4. Now what factoring method do we use when there are 3 terms? That's a box method problem. So let's go ahead and do the box method. The first term goes here. The last term goes here. And we look for 2 numbers that multiply to make each. So what times what makes t squared? That would be t and t. What times what makes 4? Well, that could be positive 2 and positive 2. Or it could be negative 2 and negative 2. Or it could be 4 and 1. Or it could be negative 1 and negative 4. There's 4 possibilities. I'm going to try positive 2 first and see if it works. We know it works if when we multiply these together, and we multiply these together, and then add those 2 results together, we know it works if what they add up to is the middle. And it works, so we've done it right. So the factorization is t plus 2 and t plus 2. But once again, we want to go ahead and go that one extra step now where we replace the t with what it represents, and it represents tangent. So there's my final answer there. So that's factoring expressions with trigonometric expressions in there. So here's a student practice for you guys. Go ahead and pause the video and give these 4 problems a try. When you unpause it, you will see the solution for each one. All right, guys, so here are the solutions. Number 1 was a difference of squares, and this is what you should have gotten. Number 2 was another difference of squares, and this is what you should have gotten there. Number 3 was a GCF problem, and number 4 was a box problem. So there are the solutions for your student practice number 1. So now that we know how to factor trigonometric expressions, we're going to use that skill now to simplify some expressions and prove that these expressions are equal to each other. So let's go ahead and take a look at example 2. All right, so since we're practicing factoring today, that means obviously there's going to be some factoring in here somewhere. So see if you guys can spot it. Do you guys see where the factoring is located? It's located right here, okay? So let's take a minute and just on the side really quick, let's do what we just did on the last slide. I'm going to replace cosine with a c, so it's going to be c squared minus 4. Now what factoring strategy would we apply to that? That would be a difference of squares, so I would have c minus 2 and c plus 2, which means that it would be cosine of x minus 2, followed by a cosine of x plus 2. And so that's what I'm going to do first, is I'm going to replace this up here with the factored result. Now remember, from now on, I want us to write what we're doing in words off to the side, okay? So I'm going to write what I just did here. I'm going to put factor. I just factored the numerator, okay? All right, now the next thing I'm going to do, now what do we need to do to get to prove these two sides are the same? Well, you guys may notice that the top and the bottom of the fraction both have a cosine of x plus 2. So that means that these can divide each other out, and that's reducing. So I'm going to put my step there. And as a result, I have cosine of x minus 2 is equal to cosine of x minus 2. And I'm all done because I've proven that those two expressions are equal. Okay? So you have to start by identifying where is the part that I'm going to factor. All right, guys, let's go ahead and let you try one of these. So go ahead and pause the video and try to do this problem here. Make sure you write the steps for what you did on the side like I did. All right? All right, guys. guys, so there's the solution. Same thing, difference of squares, just factor and reduce, and they end up matching. Let's go ahead and move on to example number 3. So once again, let's take a moment and see if we can identify where the factoring is. Do you guys see where we can factor? Well, it's probably got to be this one, right? I mean, you can't do anything with one or cotangent, so it has to be the other one, right? But what kind of factoring strategy can we use? Is it difference of squares? Is it a GCF? Or is it a box method? Well, it can't be a difference of squares because we are adding these things together. It can't be a box method because there's only 2 terms. Box methods require 3. So what must it be? It must be GCF. So what do these expressions have in common? What can I factor out of both of those? Well, they both have a cotangent. And so let's go ahead and write on the side. I've got cotangent times sine squared plus cotangent times cosine squared. I'll put an O for cosine. All right, so what do these two have in common? Well, they both have the C, so I could take the C out, and that leaves me with this. And that's as good as it gets. So we have cotangent x is what the C represented. Sine x is what the S represented. And cosine represented the O. So there's that. So if we factor this, we end up with what we just got over there. Cotangent of x times sine squared x plus cosine squared x over cotangent. And we just factored once again there. Okay? Now what can we do? Well, we can reduce. Those go away, right? So we reduce. And all we're left with now is sine squared x plus cosine squared x equals 1. And how the heck am I going to get this to equal 1? Well, it's a Pythagorean identity. That actually equals 1. And now I got the two sides the same, and so we're done. So I used a Pythagorean identity there. And now we got the sides the same. All right, so we factored using the GCF method. We reduced, and then we used a Pythagorean identity, and we got there. Okay, so now it's your turn. Student practice number 3. Go ahead and pause the video here and give this one a try. When you unpause it, I'll have it all worked out for you. All right, guys, here you go. So on this expression, we can take a sign out. And what's a likely mistake that I see a lot of students make is they'll forget to put the 1 here. Because maybe you wrote it like this. And so we see that they both have an S, so we take an S out. So if we take an S out of here, that leaves a C squared. But a lot of times people think if I take an S out of here, it leaves nothing. That's not true. Remember, we're dividing an S out. So if you divide S by S, it does leave a 1 there, okay? The next step is to reduce. We have the signs there in common. And this is a Pythagorean identity, and equals sine squared x, and that makes the sides equal. And so my steps are factor, reduce, and Pythagorean identity once again. Let's go ahead and move on to one more example in student practice for the day. All right, so for this one, we have tangent to the 4th power plus 2 tangent plus 1 equals secant to the 4th power. All right. Oh, this is tangent squared. My bad. Should be a square there. All right. Well, when there's 3 terms like that, that's a box method problem. So let's go for it. Let's do the box method. We have t to the 4th goes here, 1 goes here, and we're looking for 2 things that multiply together to make t to the 4th, which is probably going to be t squared and t squared. And for the 1, it'll be 1 and 1 probably. And so we go ahead and fill in our blanks here, and we check our answer to make sure it's right. These 2 should add up to make the middle, which they do. And so we have t squared plus 1 times t squared plus 1, and that should be equal to s to the 4th. Now, once again, we're going to replace these t's and s's with what they really are. Okay, now what? So the first thing we did was we factored. This one was a box method problem because we had 3 terms. All right, so now what do we do now that we factored? Well, I see another Pythagorean identity here. What does tangent squared plus 1 equal? Well, tangent squared plus 1 is equal to secant squared x. And these are the same, so you just have that twice. Okay. Well, if you have secant squared times secant squared, you're just going to add those exponents together, and you end up getting secant to the 4th. And now we have both sides equal to each other. Okay? And that, we would call that just simplifying, or you can call it multiplying. It doesn't really matter. So we factored, we did a Pythagorean identity, and then we simplified, and we got our answer. All right, one more student practice for you here. So go ahead and pause the video. Give this one a try. Now, I'll give you a little heads up. There are 2 things that you need to factor on this problem, okay? But when you unpause the video, I'll have all the solutions up for you. All right, guys, there's your solution. You would factor this one using the box method, and you would get this as a result. You would factor this one using the difference of squares method, and you would get that. And then these cancel out, and we have our 2 sides equal to each other, and we're done. So basically, we just had to factor and reduce on that one. And that's it. So that's how factoring can be used to rewrite expressions. So we'll go ahead and put this to practice in class next time. So until then, have a good one.